Hello, and welcome to this lecture on map projections. The learning objectives for this lecture are to understand what map projections are and discern the differences between different map projection types. The Earth is an oblique sphere. Thus, starting with the ancient Greeks and the beginnings of Earth measurement and graphical representation, a practical need developed for map projections. A map projection is a method of representing the Earth's three-dimensional surface as a flat, two-dimensional surface. The following list outlines key points you should know about map projections. Projections are mathematical transformations. Scale is true in only certain places. Many different types have been devised. All map projections distort. Distortion characteristics vary from projection type to type. Some types are better for some applications than others. And a few types are widely used. The idea of projecting a map is that a hypothetical light source is placed in the center of a scale 3D model of the Earth. From this center point, the light would then shine out or project the lines of latitude and longitude onto a two-dimensional projection surface, which would then be the basis for the map projection. All map projections are based on three common projection surfaces. The cylinder projection surface, used for cylindrical projections. In this case, the projection surface is tangent or in contact with a single point or line of the globe. The cone projection surface, used for conic projections. In this case, the projection surface is secant with the globe or cutting intersecting through the globe. The plane projection surface, used for planar or azimuthal projections. In this case, the projection surface is tangent with the globe. The heavy black lines and black point on the top of the globe shown in these figures are what are known as standard lines. Standard lines are where the map projection surface touches the globe model. The standard lines are the only place of the map where the scale is true. For example, take a look at the left side of the bottom left figure. Note how there is a straight black line where the projection plane or standard line is in contact with the Earth's surface. Contrast this to the dotted line above the projection plane and map surface. This will show distorted features as the map surface is farther away from the projection plane and points of contact with the globe model. Creating a map projection distorts the spatial properties of the final two-dimensional map. Spatial properties that are distorted include distance, area, shape, and direction. When a flat map is made, choices are made dependent on the intended use of the map as to which of these properties to preserve. Thus, distortions exist in all two-dimensional flat maps, as no map projection can preserve all of these properties. And map projections are classified based on the spatial property they preserve. Here we see some map projection examples. In these figures, the general projection class is listed with the name of the specific projection shown in parentheses. The conformal map projection, which preserves shape and angle and is shown on the top left, clearly illustrates how shapes are preserved, but size and area is greatly distorted, as seen in the size and area of Greenland and Antarctica when compared with Africa. The equal area projection, which preserves area and size and is shown on the top right, shows features at their correct size and area, but not their correct shape. This time, Africa is shown correctly in terms of size and area when compared with Greenland and Antarctica. The equidistant projection, shown on the bottom left, preserves true distances in some directions from the projection center or along special lines. As seen in this example, you could calculate correct distances from the North Pole. The azimuthal projection preserves true direction or azimuth or angle measurements from a reference point. In this example, the map is centered on 0 degrees latitude and 0 degrees longitude. Thus, any direction measured from this point will be correct. In the following example, I use geographic information systems to give you some practical examples of map projections. In this example, I demonstrate map projection ideas using a commercial geographic information system tool known as ArcMap, created by ESRI. ArcMap makes it very easy to change and manipulate map projections. In this example, you can see world country outlines. To change the map projection, I right-click on the data frame layer properties, and I'm given a variety of choices of map projections I can use. For example, if I wanted to create a conformal map projection to show how shapes and angles are preserved, I can select World and Mercator. Note how the country shapes in this part of the map will change when I hit the OK button. Here you can now see the Mercator map projection, which is preserving shapes and angles. I can continue this idea with other map projection types. For example, an equal area projection. Although ArcMap makes it very easy to change map projections using simple button clicks, remember it is important to keep the concepts of map projections in mind. In this lecture, you learned about map projections. You learned what map projections are. Specifically, you learned that map projections are a two-dimensional representation of the Earth, which is a three-dimensional entity. You learned that map projections involve using a variety of projection surfaces such as cylinder, cone, and plane. These projection surfaces have influence on where scale is true on the map. You then learn the differences between different map projection types. You learn that map projections make distortions in spatial properties such as distance, area, shape, and direction. You were also shown examples of different map projection types to see specifically how spatial property distortions affect the geography shown on a map. You were also given a brief demonstration of how to manipulate map projections using a commercial GIS tool. Whenever you look at any map now, keep the ideas of map projections in mind and consider if the map maker is using the correct map projection for the geography being shown. The following are references used in the preparation of this video lecture. If you enjoyed this video lecture or have any comments or questions, feel free to contact me at the email address below. Thank you for watching.